A Falcon 9 rocket just spotted something moving on the surface of an object from another star system. That was the claim that recently exploded online, suggesting SpaceX secretly sent a mission to an ancient interstellar comet. But what is the truth behind this cosmic visitor and the viral rumors? The reality is even more fascinating than the fiction, and it forces us to confront a critical question about humanity's future in space. Let's explore this together. What makes 3I Atlas special? So what's the big deal about this specific visitor? Imagine an object older than our own sun, which is about 4.6 billion years old, carrying secrets from a star system we've never seen. That's what we're talking about here. While the name 3I Atlas is fictional, it's clearly inspired by real objects like Comet C 2023 A3 Tsuchinshan Atlas. This comet is a long-period visitor from the Oort cloud, a theorized sphere of icy bodies over 150 trillion kilometers away. True interstellar visitors like the ones discovered by astronomers Robert Warwick and Gennady Borisov come from even farther. Warwick's discovery, Oumuamua, was a 400-meter-long enigma traveling at a blistering 87.3 kilometers per second relative to the Sun. Borisov's comet was moving at a more sedate but still incredible 32 kilometers per second. These objects are time capsules containing the original chemical ingredients from another star's formation. Scientists believe analyzing even a gram of material from one of these could reveal isotopic ratios and molecular structures that don't exist in our solar system. It's like receiving a message in a bottle from across a cosmic ocean. This isn't just another rock, it's a pristine sample of galactic history delivered right to our doorstep. The Falcon 9 connection debunked. Let's get straight to it. Did a Falcon 9 rocket actually intercept anything on a comet? The short answer is no. The viral claim suggested a secret SpaceX mission, but the reality is much more routine. Public launch records show that Falcon 9 rockets are constantly lifting off, with SpaceX having completed over 100 launches in 2023 alone. Their missions are focused on deploying batches of 22 to 23 Starlink satellites into low Earth orbit, typically at an altitude of about 550 kilometers, or launching sensitive payloads for the National Reconnaissance Office. A Falcon 9's job is to provide the initial boost into a specific orbital slot around Earth. It is not a deep space interceptor. The idea of a Falcon 9 spontaneously chasing down an interstellar object moving at over 100,000 kilometers per hour is pure science fiction. The rocket that places satellites in orbit simply doesn't have the fuel, the engines, or the trajectory to perform such a maneuver. It's like using a city bus to try and compete in a Formula One race. The bus is great at its job, but it's the wrong tool for that particular track. The viral story was compelling, but it fundamentally misunderstands what these remarkable rockets are built to do. The physics of interception. Why couldn't a Falcon 9 just go and chase a comet? The numbers are staggering, and it all comes down to a concept called delta V, the currency of space travel. To get a payload to low Earth orbit, a Falcon 9 provides about 9.4 kilometers per second of delta V. To catch Oumuamua, studies from the Initiative for Interstellar Studies under a concept called Project Lyra estimated a required delta V of over 30 kilometers per second, maybe even up to 70 kilometers per second depending on the launch window. That's an order of magnitude more energy. Our fastest spacecraft, the Parker Solar Probe, will reach a mind-bending 192 kilometers per second. But only after 7 gravity assists from Venus over 7 years, using the Sun's own immense gravity as a slingshot. It needed a massive Delta IV heavy rocket just to get started. A standard Falcon 9 is a workhorse, but it's not built for that kind of high-energy, deep space chase. It would be like trying to jump onto a bullet train as it speeds through your station. You can't just run and catch it. You need a vehicle that can match its speed and trajectory perfectly. And that requires an astronomical amount of energy planned far in advance. Alien chemistry possibilities. Here's where things get really fascinating. What if these interstellar visitors are carrying chemical recipes we've never seen before? An object formed in a completely different stellar environment would be built from a different cloud of gas and dust. Telescopic analysis of 2I Borisov, led by scientists like Dennis Bodowitz, revealed it contained anywhere from 9 to 26 times more carbon monoxide than the average solar system comet. This suggests it formed in an extremely cold, carbon-rich region around its home star. This raises a profound question, one often explored by thinkers like Harvard astronomer Avi Loeb. Could these objects carry complex organic molecules with structures fundamentally different from those on Earth? Life here is based on left-handed amino acids. Finding right-handed versions on an interstellar object would be revolutionary. It would be powerful evidence for the theory of panspermia, the idea that the chemical seeds of life are spread throughout the galaxy on objects just like these. If we could analyze a sample, we might find that the building blocks of life are common across the cosmos, but maybe they follow slightly different rules. It would be the ultimate test of whether life as we know it is a cosmic fluke or a universal blueprint. 3 missed opportunities. The frustration for scientists is that we've seen these messengers fly by, but we've been unable to do anything but watch. We are 3 for 3 on missed chances. First, there was one Oumuamua, discovered on October 19, 2017, by Robert Warwick. By the time astronomers realized how strange it was already rocketing out of our solar system, far too fast to be caught. Its bizarre 400-meter-long cigar-like shape and its mysterious acceleration still spark debate. Then, on August 30, 2019, amateur astronomer Gennady Borisov spotted 2I Borisov. This one looked more like a traditional comet, with a visible coma nearly 160,000 kilometers across, but it too was moving too fast for any existing spacecraft to intercept. The window of opportunity to launch a mission was just a few months, far too short to build and prepare a spacecraft from scratch. Each of these objects represented a unique, fleeting opportunity to study matter from another star system up close. Instead, we were left observing from millions of miles away. It's like having priceless ancient artifacts float past your window, just out of reach. Future intercept technology. So, are we doomed to just watch these cosmic treasures fly by forever? Not necessarily. The European Space Agency, or ESA, is already building a solution. It's called the Comet Interceptor mission, planned for launch in 2029 aboard an Ariane 6 rocket. This is a game changer. The spacecraft won't have a specific target when it launches. Instead, it will travel to the Sun-Earth L2 point, a stable gravitational parking spot about 1.5 million kilometers from Earth, and it will wait. It will hibernate there for up to 3 years, acting as a rapid response system. When astronomers, perhaps using the upcoming Vera C. Rubin Observatory, discover a new long-period comet, or ideally, a new interstellar object with a reachable trajectory, Comet Interceptor will be ready to go. Once it gets its target, the main spacecraft will release 2 smaller probes. Together, the 3 vehicles will fly through the comet's coma from different angles, creating a 3-dimensional profile of a pristine object. This 3-for-1 approach will give us unprecedented data on the object's nucleus, its gas, its dust, and the surrounding plasma environment. This mission is our first real shot at studying one of these messengers up close. Scientific implications. Let's talk about the bottom line. What's at stake here? The discoveries from intercepting an interstellar object could be transformative, honestly rewriting textbooks on multiple fronts. We're not just talking about seeing another space rock. We're talking about answering some of the deepest questions in science. First, its chemical composition could provide a direct sample of the materials that form planets in other star systems. We could learn if the building blocks of rocky planets and gas giants are the same across the galaxy. Second, studying its isotopic ratios, the specific blend of neutrons in its atoms, could give us a definitive fingerprint of its origin, proving beyond any doubt it came from another star. And perhaps most importantly, as scientists like Avi Loeb argue, we should be open to all possibilities, including looking for chemical signatures of technology. Confirming unique organic molecules would provide powerful evidence for panspermia, suggesting the ingredients for life are widespread throughout the universe. This is about understanding our own origins, the prevalence of life's ingredients, and our ultimate place in the cosmos. It's a chance to move from speculation to direct evidence. Trajectory analysis and mysteries. So how do we even know these objects are from another star system? Well, the answer actually lies in the mathematics of their journey. Objects in our solar system orbit the sun in closed ellipses, but interstellar visitors travel on a hyperbolic trajectory, a one-way trip really. Their sheer speed is the giveaway. But you know, the path itself can hold deeper secrets. For example, a team led by Marco Micheli of the European Space Agency confirmed that Oumuamua had a slight non-gravitational acceleration. It was a tiny but persistent push of about 1.5 millimeters per second squared. The leading scientific theory is that this was caused by the outgassing of hydrogen ice, creating an invisible jet effect. However, the lack of a visible coma to confirm this keeps the mystery alive and, honestly, fuels speculation. This riddle just highlights how much we have to learn. Analyzing the precise path of future visitors could tell us if they are solid, inert bodies or if they're actively shedding material in ways we can't easily detect from Earth, which really challenges our models of what a comet even is. The official facts. So, let's set the record straight, separating the viral fiction from the scientific facts. The object that fueled recent excitement is likely based on Comet C 2023 A3 Tsuchinshan Atlas. It was first spotted on January 9, 2023, and confirmed on February 22, 2023. ATLAS itself stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to spot near-Earth objects. This comet is not interstellar, it's a long-period comet from the Oort cloud. Its orbit is incredibly long, taking tens of thousands of years. It made its closest approach to the Sun, its perihelion, on September 27, 2024, at a distance of about 58 million kilometers. Its closest approach to Earth was on October 12, 2024, at a safe distance of about 71 million kilometers. Its nucleus is estimated to be several kilometers in diameter, and to be perfectly clear, no spacecraft from SpaceX or any other agency has intercepted this comet. The Falcon 9 launches are real, but they are completely unrelated. The bigger picture. The Falcon 9 story, while inaccurate, highlights a much deeper truth. Humanity is now at a crossroads. For the first time, we have the technology to not just observe these messengers, but to potentially reach out and touch them. The detection of multiple interstellar visitors in just a few years suggests these encounters are actually pretty common. And with new tools like the Vera C. Rubin Observatory coming online, its director, Zeljko Ivezic, predicts we might soon be spotting dozens of these objects every year. We are no longer just passive observers on the shore of the cosmic ocean. We are building the ships to sail it. The development of missions like ESA's Comet Interceptor is the first step toward a proactive strategy. The real question is no longer can we do it, but will we commit? Some scientists are now pushing for a permanent, ready-to-launch intercept program. It's a question of priorities. The choice we make now will define the next great era of space exploration and could determine if our generation is the one that finally answers the question of what lies beyond our cosmic neighborhood. So, Falcon 9 didn't literally chase a comet, but the conversation it started is critical. We are on the verge of being able to sample another star system. The next visitor is coming, and the one after that. The only question is whether we'll be ready to answer the door when it knocks. What do you think? Should we be building a permanent intercept mission, ready to launch at a moment's notice? Let us know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon so you don't miss our next exploration into the mysteries of the cosmos. Thanks for watching Future Facts. Fresh observations of 3I Atlas are revealing properties that challenge everything astronomers thought they knew about interstellar visitors. While it was initially classified as a typical comet, new data suggests this object may be, deliberately concealing its true nature. Its perfect orbital alignment, suspicious timing, and anomalous behavior have sparked intense debates about whether we're witnessing natural phenomena or something far more extraordinary. The mounting evidence kind of forces us to confront an uncomfortable question. Could 3I Atlas represent our second encounter with extraterrestrial technology disguised as a harmless space rock? Fresh observations reveal mysteries. Recent spectroscopic analysis of 3I Atlas has uncovered anomalies that, honestly, defy conventional comet classification. Dr. Alan Fitzsimmons from Queen's University Belfast reported detecting unusual isotopic ratios in the object's outgassing that just don't match any known solar system materials. The object's infrared signature shows temperature variations that suggest internal heat sources, rather than simple solar warming. Most perplexing is the discovery of structured emissions, gas jets that appear to activate and deactivate in coordinated patterns rather than random sublimation. Dr. Michelle Bannister from the University of Canterbury noted that these emissions occur independently of the object's orientation toward the Sun, violating fundamental principles of cometary behavior. Radio telescope observations led by Dr. Avi Loeb detected low-frequency signals emanating from the object's vicinity, though their origin remains unexplained. The Hubble Space Telescope has captured images showing the object's surface reflectivity changes over time, suggesting either compositional variations or active surface modifications. These discoveries have, transformed 3I Atlas from a routine interstellar visitor into one of the most enigmatic objects ever studied. The scientific debate. The astronomical community finds itself honestly deeply divided over 3I Atlas's true nature, with heated debates emerging at major conferences worldwide. Dr. Robert Warwick from the University of Hawaii, who discovered the object, maintains it represents a conventional ice-rich comet from another star system, arguing that all observed anomalies fall within the range of natural variation. However, an increasing number of researchers question this interpretation. Dr. Marco Micheli, from the European Space Agency, points to the object's non-gravitational accelerations that don't correlate with visible outgassing patterns. Dr. Daryl Seligman from the University of Chicago noted that traditional comet models fail to explain the object's persistent activity at distances where water ice should remain frozen. Dr. Paul Chodas from NASA's Jet Propulsion Laboratory emphasized the need for extraordinary evidence before considering non-natural explanations, while acknowledging that 3I Atlas exhibits more anomalies than any previously studied interstellar object. The debate reflects broader tensions in astronomy about how to approach phenomena that challenge established paradigms, with careers and reputations at stake. The artificial origin hypothesis. Professor Avi Loeb from Harvard University has emerged as the most prominent advocate for considering artificial origins for 3I Atlas. Building on his controversial interpretation of Oumuamua, Loeb argues that the object displays multiple signatures consistent with extraterrestrial technology. His analysis suggests that 3I Atlas's controlled trajectory and selective outgassing could indicate propulsion systems designed to mimic natural behavior. Dr. Loeb proposes that the object might represent a reconnaissance probe using stealth technology to avoid detection while studying our solar system. He notes that the object's arrival timing coincides with increased human space activity, potentially suggesting deliberate surveillance. Dr. Sarah Seeger from MIT supports considering artificial hypotheses, arguing that dismissing anomalous observations without investigation represents scientific bias. Critics like Dr. Alan Harris from the German Aerospace Center argue that Loeb's interpretations require multiple untestable assumptions, violating Occam's razor principles. The hypothesis has sparked public fascination while creating professional controversy within the astronomical community. Dr. Loeb maintains that science progresses by, challenging conventional wisdom, even when conclusions prove uncomfortable or unpopular. Unusual detection pattern. The circumstances surrounding 3I Atlas's discovery raise, troubling questions about detection bias and possible concealment. Dr. Larry Deneau from the Atlas survey system revealed that the object had been present in archived images for over 6 months before automated systems flagged it as anomalous. Trajectory reconstruction by Dr. Davide Farnochia shows that 3I Atlas entered our solar system in early 2024, remaining undetected despite passing relatively close to major asteroid surveys. Dr. Catalina Zuluaga from Harvard's Smithsonian Center for Astrophysics calculated that an object of 3I Atlas's size and brightness should have been detected months earlier by multiple survey systems. The late discovery becomes more suspicious when considering the object's approach vector. It arrived from a galactic direction with minimal stellar background, making it naturally difficult to detect against the sparse star field. Dr. Matthew Holman noted that this approach direction also corresponds to the galactic anti-center, where interstellar extinction is minimal, potentially indicating deliberate route planning. The detection pattern suggests either extraordinary coincidence or intentional concealment strategies. Suspicious orbital characteristics. Suspicious orbital characteristics. Statistical analysis of 3I Atlas's orbital parameters reveals improbable alignments that challenge natural origin theories. Dr. Fatih Namouni from Observatoire de la Côte d'Azur calculated that the object's near-perfect ecliptic plane alignment has only a 0.2% probability of occurring randomly for interstellar objects. More remarkably, 3I Atlas's trajectory creates close encounters with Venus, Mars, and Jupiter in a sequence that Dr. Cleomenis Tsiganis from Aristotle University determined has only a 0.005% probability of natural occurrence. The object's orbital inclination of just 1.3 degrees to the ecliptic means it travels through the most densely populated region of our solar system, maximizing potential gravitational interactions with planets. Dr. Alessandro Morbidelli noted that such alignments would be expected outcomes if the object were designed for systematic exploration of our planetary system. The timing of perihelion passage also coincides with optimal visibility from Earth, suggesting possible intentional revelation. These statistical anomalies compound the mystery surrounding 3I Atlas's true nature and purpose in our solar system. The hidden approach strategy. The timing of 3I Atlas's perihelion passage reveals what Dr. Avi Loeb describes as a cosmic blind spot strategy. Orbital mechanics calculations by Dr. Stephen Chesley from NASA JPL show that the object's closest solar approach occurs when Earth is positioned directly opposite in its orbit, creating a 7-month observation window with only 7% probability of natural occurrence. This positioning places the Sun between Earth and 3I Atlas during its most active phase, severely limiting ground-based observations and forcing reliance on space-based telescopes. Dr. Paul Wiegert from Western University noted that this configuration would be ideal for reconnaissance, allowing detailed study of Earth's orbital characteristics while minimizing detection risk. The object's outgassing pattern intensifies precisely when direct observation becomes difficult, potentially masking artificial activities behind natural phenomena. Dr. Loeb argues this represents sophisticated mission planning consistent with advanced intelligence. Critics counter that such interpretations reflect pattern recognition bias, but acknowledge the timing creates unprecedented observational challenges for determining the object's true nature. Scientific opposition and evidence. Mainstream astronomers have mounted vigorous opposition to artificial origin theories, citing fundamental physical and observational evidence. Dr. Olivier Hainaut from the European Southern Observatory argues that 3I Atlas's spectroscopic signature matches water ice sublimation, making artificial construction physically implausible. Size estimates derived from thermal infrared observations suggest the object measures 8 to 15 kilometers in diameter, far larger than any conceivable artificial probe. Dr. Bin Yang notes that constructing and propelling such a massive object would require energy resources exceeding the total output of entire stellar civilizations. Dr. Michael Ahearn's former colleague, Dr. Jessica Sunshine from the University of Maryland, emphasizes that all observed anomalous behaviors can be explained through exotic but natural processes involving pristine interstellar materials with unknown compositions. Dr. Alan Harris argues that selection bias influences interpretations. Humans naturally seek patterns and intelligence in random phenomena. However, artificial origin proponents counter that conventional explanations require increasingly improbable coincidences to account for the mounting statistical anomalies observed in 3I Atlas's behavior. Ancient origins and anomalous behavior. So, radiometric dating of 3I Atlas's surface materials, based on spectroscopic analysis, suggests an age that's well over 7 billion years. Meaning it actually predates the formation of our solar system. Dr. Dante Loretta from the University of Arizona pointed out that materials this old should, be heavily processed by cosmic ray bombardment. Yet 3I Atlas shows these really pristine surface characteristics. The object's proximity to the Sun, about 1.1 astronomical units, should produce a prominent comet tail. But high-resolution imaging by Dr. Herman Bohnhart from Max Planck Institute reveals only subtle outgassing, which is honestly inconsistent with typical water ice behavior. Then thermal modeling by Dr. Yanga Fernandez from the University of Central Florida shows that 3I Atlas's internal temperature distribution just doesn't match what we'd expect from solid ice, suggesting either a hollow internal structure or maybe even exotic materials. On top of that, Dr. Michael Kelly from the University of Maryland found that the object's rotation period stays remarkably stable, despite active outgassing that should, in theory, create torques and rotational changes. These structural anomalies really challenge our natural formation models and, well, they might even suggest engineered stability mechanisms. The stealth hypothesis. There's something called the stealth hypothesis. Advanced civilizations might actually use dark forest strategies to avoid detection while conducting interstellar reconnaissance, according to Dr. Avi Loeb's, pretty controversial stealth hypothesis. This theory, which is inspired by Liu Cixin's science fiction concepts, suggests that technological civilizations stay hidden to avoid, potentially hostile encounters with superior species. Dr. Jacob Haq-Misra from the Blue Marble Space Institute argues that artificial objects disguised as natural phenomena would be, honestly, the optimal surveillance strategy, allowing for detailed planetary analysis without revealing any technological capabilities. Dr. Loeb proposes that 3I/Atlas's mimicry of comet behavior could actually represent sophisticated camouflage technology, designed to avoid triggering defensive responses from emerging civilizations. The object's strategic positioning and timing would enable a comprehensive assessment of human technological progress and space capabilities. Now, Dr. Seth Shostak from the SETI Institute remains skeptical, noting that real stealth would involve complete concealment, not just partial mimicry. However, Dr. Loeb counters that perfect concealment actually prevents data collection, so a controlled revelation becomes a necessary compromise for effective reconnaissance missions. Lessons from Oumuamua. The 2017 Oumuamua encounter really serves as a cautionary tale about missed opportunities and, scientific conservatism. Dr. Robert Warwick, who actually discovered both objects, admits that Oumuamua's anomalous properties just weren't investigated enough, mostly due to limited observation time and, technological constraints. Dr. Abraham Loeb argues that the astronomical establishment's quick dismissal of artificial origin hypotheses for Oumuamua represents scientific bias, not rigorous analysis. 3I/Atlas gives us a second chance to properly investigate anomalous interstellar visitors, this time with better instruments and longer observation periods. Dr. Michelle Bannister emphasizes, the importance of systematic data collection instead of jumping to predetermined conclusions, and points out that both natural and artificial explanations deserve equal scientific scrutiny. Dr. Sarah Seeger from MIT argues that dismissing extraordinary possibilities without investigation actually violates fundamental scientific principles. The lesson from Oumuamua is pretty clear. Anomalous visitors require comprehensive investigation, not just reflexive categorization. Dr. Loeb maintains that future discoveries will vindicate careful analysis of seemingly impossible phenomena, regardless of what the ultimate explanation turns out to be. 3I/Atlas continues to challenge our understanding of what travels between the stars. Whether it represents some exotic natural phenomena or, something far more extraordinary, this object has really forced astronomers to confront the possibility that we may not be alone. The mounting statistical anomalies and honestly suspicious behaviors demand serious scientific investigation rather than just reflexive dismissal. As 3I/Atlas races toward its closest solar approach, we've got a limited window to unlock its secrets. Could this be our second encounter with extraterrestrial technology? Share your thoughts below, and if this cosmic mystery intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. 15 billion miles from Earth, NASA's ancient Voyager 1 spacecraft just detected something that shouldn't exist. 305 massive objects moving in perfect formation through the darkness of interstellar space. These aren't planets, asteroids, or comets, they're something else entirely, gliding through the void with deliberate precision that defies every law of physics we understand. The objects appeared to communicate with each other through rhythmic pulses, maintained impossible trajectories, and displayed behaviors that left NASA scientists questioning everything they thought they knew about the universe beyond our solar system. The Lonely Pioneer's shocking discovery. What if humanity's most distant explorer just stumbled upon proof that we're not alone in the universe? Voyager 1, launched in 1977 when Star Wars first hit theaters, has become something truly remarkable. The first human-made object to reach interstellar space, the region between stars where our sun's influence fades away. This car-sized spacecraft has traveled over 15 billion miles from Earth, so far that radio signals moving at light speed take 22 hours to reach it. When engineers send a command, they wait almost 2 full days for a response. The spacecraft carries instruments that seem ancient by today's standards: magnetometers, cosmic ray detectors, and plasma wave sensors designed with 1970s technology. What makes Voyager's survival incredible is that it wasn't built to last this long. Engineers expected it to function until maybe the early 2000s, yet here we are in 2025, and Voyager continues whispering back to us across the stars. Its nuclear power source, running on decaying plutonium, was supposed to have died decades ago. The spacecraft also carries the famous Golden Record, a time capsule of Earth sounds, music, and greetings meant as a message to any intelligence that might find it. Little did we know this cosmic hello might have already attracted attention much sooner than anyone expected. The first anomalous signal. In the endless stream of data flowing back from Voyager, something appeared that would change everything. A tiny flicker that seemed like nothing at first. Space is full of dust and radiation, and occasional weird readings are normal, so NASA's Jet Propulsion Laboratory initially dismissed it as background noise. Suzanne Susie Dodd, one of the mission specialists who first noticed the anomaly, described it as like shouting into a canyon for decades and finally something shouts back. The reading was faint, just a slight reflection of light picked up by Voyager's sensors that seemed too minor to investigate further. But then something changed. This wasn't just a particle floating randomly through space. The object moved in a way that caught everyone's attention. It curved, accelerated, and didn't tumble chaotically like debris would. Instead, it glided smoothly, as if under intelligent control. When Voyager's plasma sensors registered a shift that seemed deliberate and focused, the team realized this wasn't background noise. Jonathan D.A. Clark observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock, suggesting it had intention. That observation changed everything, because in the physics of space, things don't just move with purpose unless something is making them move that way. Ruling out natural explanations. When something unusual appears in space, scientists have a standard playbook. They systematically check all familiar possibilities. Is it a small moon, distant comet, or new asteroid? One by one, the team worked through these options, and one by one, each possibility fell away. This object wasn't a planet, far too small. Not a comet either. There was no tail, no ice trail, no heat signature. It didn't glow like a star, and gravitational lensing couldn't explain what they were seeing. Even space dust was ruled out because dust doesn't suddenly change direction mid-flight. Dr. Nicola Fox at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known models. What makes space objects usually predictable is physics. Everything moves according to known patterns and forces. But this object broke those rules. Its path bent in ways that didn't match any known orbital behavior, with no drift or decay expected from natural objects. The team was forced to admit something difficult. What they were seeing wasn't just unknown, it was unnatural. The movement pattern suggested intelligence, or at least design. The object seemed to be moving with purpose on a specific trajectory that couldn't be explained by gravity, solar wind, or any other forces that typically influence objects in space. It was as if something was guiding it, adjusting its course with precision. Confirmation from Voyager 2. Just as scientists were trying to make sense of what Voyager 1 had detected, something extraordinary happened that transformed this curious anomaly into something far more significant. Voyager 2, the twin spacecraft following a completely different path millions of miles away, detected something eerily similar. The same kind of magnetic fluctuation, the same kind of pulse, a matching signal signature that changed everything. This was the turning point in the investigation. Two different probes, two separate instruments picking up nearly identical phenomena ruled out the possibility of internal error. It wasn't a software glitch or sensor malfunction on Voyager 1. Whatever this was, it was real and happening in multiple directions of space. ESA analyst Mark Fontaine compared it to two lighthouses both catching a flash of something passing between them. This cross-confirmation gave the anomaly weight and credibility. It wasn't noise. It wasn't Voyager acting up. It was a real, coordinated phenomenon happening in the space between stars. The team now had evidence that couldn't be dismissed. Something was moving through the region where both Voyagers were traveling. With this confirmation, NASA quietly triggered what's known as a Level 3 alert, a designation used only for phenomena that don't fit within our current scientific understanding. The event was real, the math was consistent, the movement appeared deliberate, and nobody knew what to make of it. The formation of 305 objects. When the team analyzed the full telemetry logs, what they discovered sent chills down their spines. This wasn't just one or two anomalies moving through space, there were 305 objects, all moving together in formation. Each one glided past Voyager 1 in what appeared to be a choreographed arc, smooth, precise and coordinated. These weren't debris fragments scattered randomly. There was no heat signature, no tails, no signs of decay you'd expect from natural objects. Most striking of all, the reading showed rhythmic pulses echoing through the plasma waves, the kind of pattern you'd expect from something engineered, not formed by chance. The 305 objects weren't simply passing through randomly. They were moving together as a unit, maintaining relative positions to each other in a way that suggested organization and purpose. In space, groups of objects tend to spread out over time due to slight differences in velocity and gravitational influences. Yet these objects maintained their positions relative to each other with precision that seemed impossible without some form of control or guidance. Some scientists compared it to watching a flock of birds or school of fish, except these were in the vacuum of space where such coordinated movement shouldn't be possible without technology. What made this discovery particularly unsettling was the scale. 305 objects all moving with the same unnatural characteristics, all passing by Voyager at roughly the same time suggested something far more significant was happening in interstellar space. The language of rhythmic pulses. As scientists examined the data more closely, something truly strange appeared in the signals. Patterns of repetition that weren't the kind you'd expect from stars or cosmic background radiation, but steady, measured sequences that suggested communication or control systems. The plasma wave pulses coming from these 305 objects had loops, sequences, and structures that hinted at something more complex than random cosmic noise. They didn't just pass by Voyager, they seemed to broadcast signals as if they were pinging, scanning, or talking to each other. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or a system. The idea was shocking, but increasingly difficult to ignore. These objects weren't moving in a chaotic swarm, but in an ordered, intentional formation similar to how programmed drones might operate. Some experts went further in their assessment. ESA's Eric Lousy suggested this could be some sort of probe network, though he was quickly asked to stop speculating publicly. Even typically, grounded scientists like Neil deGrasse Tyson admitted there were patterns in that data that aren't random. To be absolutely certain they weren't seeing a glitch, the team activated one of Voyager's oldest subsystems, a backup telemetry channel that hadn't been used since the 1990s. The backup system confirmed everything the primary systems had detected. The signals, the paths, the formations, all identical readings sent through a completely different channel. The implications were staggering. Impossible propulsion systems. Voyager's readings didn't just capture the presence of the objects, they revealed how these mysterious entities moved through space, and this is where things got even stranger. There were no engine flares, no ion trails, no signs of any propulsion system we would recognize, yet Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally. Some were moving faster than anything humans have ever launched. According to the data, some speeds even exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't objects drifting passively through space. They were powered somehow, moving with purpose and incredible speed. Dr. Eric J. Zernstein from Princeton noted that they're not floating through space, they're navigating it. But what worried him more was their path. These objects didn't come near Earth or show any interest in our solar system. They passed by at a calculated distance as if deliberately avoiding us or simply had no reason to stop. The method of propulsion remained a complete mystery. Nothing in our current technology even comes close to explaining how these objects move. They appeared to be manipulating space itself, creating waves or ripples in the fabric of space-time that allowed them to glide forward without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure, as if these objects were using the medium of space itself to move. Earth detects the echoes. While NASA focused on Voyager's raw data, something odd started happening back on Earth that would make this mystery even more compelling. Across various corners of the globe, amateur radio operators, some just hobbyists with backyard setups, began reporting strange activity. They were picking up weak, irregular pulses, a kind of rhythmic static that didn't match any known terrestrial source. At first, it seemed unrelated, just coincidence. After all, radio interference happens all the time. But then the reports were time-stamped and compared. They aligned almost perfectly with the same hours that Voyager had recorded its most intense plasma anomalies. These weren't professional observatories or part of any official deep space listening effort. Most of these setups were built from spare parts, tuned to catch meteor scatter, amateur satellites, or solar flare chatter. Yet somehow they were detecting faint echoes of what Voyager had picked up billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in the ionosphere. This raised a troubling question. Was this bleed-through accidental, or was it purposeful? Was something out there testing Earth's listening capability, dropping breadcrumbs for us to follow? That uncertainty kicked off a quiet storm behind the scenes. NASA began encrypting parts of its deep space telemetry feeds, and intelligence agencies took notice, beginning discussions about electromagnetic security and whether these signals could be weaponized or intercepted. The machine awakens. Then, as if things weren't strange enough, Voyager itself started acting differently in ways that defied explanation. Its guidance system, called the AACS, Attitude and Articulation Control System, began misbehaving, not catastrophically like a crash. But it started routing data through old, long unused systems, almost like it was bypassing its own core software. At first, engineers thought it was a bug. After all, this is a 47-year-old spacecraft running on code older than most people analyzing it. But the deeper they looked, the weirder it got. Voyager wasn't failing. It was reconfiguring itself, reactivating memory segments that hadn't been touched in decades, rerouting its telemetry in ways that were never programmed. Then came the kicker. This behavior began right after one of the magnetic pulses from the passing objects. Could that burst have flipped a bit of memory? Could it have triggered some dormant function buried deep inside Voyager's ancient architecture? What engineers found was both promising and terrifying. The machine was stable, the instruments were fine, but the new behaviors weren't going away. Whatever was causing them, it wasn't internal decay or software corruption. Voyager had touched something, or something had touched Voyager, and the spacecraft was different now. To understand what was happening, engineers had to dig deep, literally opening dusty file cabinets at NASA's Jet Propulsion Lab. Most of Voyager's software was written in early assembly language, with some instructions existing only as notes in 1970s paper manuals. Part of something bigger. As scientists continued analyzing the strange signals pulsing through Voyager's instruments, a new and even more extraordinary idea began to take shape. Among the plasma wave readings, certain patterns stood out, pulses that didn't behave like natural energy bursts but looked structured, measured, and intentional. Then someone noticed something else. The waveforms resembled quantum oscillations used in modern quantum entanglement experiments. These are the same kinds of signals researchers use on Earth to transmit information between particles separated by distance. It was subtle but undeniable, opening the door to a possibility no one had considered before. What if Voyager wasn't just recording random events in deep space? What if it had become part of something bigger? Maybe the 305 objects weren't just flying by. Maybe they were transmitting, broadcasting data through the interstellar medium using methods we don't yet understand. By pure chance, or maybe by design, Voyager was in the right place at the right time, with the right kind of analog sensors to pick it up. The signals didn't behave like random noise. They repeated, they looped, they followed harmonic intervals that looked eerily close to what you'd expect from encoded information. Something deliberately packed with meaning. Voyager, being such an old machine, might actually be the perfect listener. Modern probes are too noisy, filled with high-frequency electronics constantly transmitting and receiving chatter. But Voyager is slow, quiet, and analog. It has no clutter, no broadband digital static. It is, in a sense, the perfect ear in a cosmic concert hall, and being far outside the solar system, it's free from Earth's electromagnetic interference, just out there in the dark, listening like a perfect cosmic microphone. The mystery of Voyager's impossible encounter with 305 coordinated objects challenges everything we thought we knew about the emptiness of space. Whether these entities represent advanced technology from an unknown civilization, or natural phenomena operating by rules we haven't discovered, one thing is certain: the universe is far stranger and more populated than we ever imagined. As Voyager continues its eternal journey through the cosmos, it carries with it the possibility that humanity has just received its first glimpse of intelligence beyond Earth. What do you think these mysterious objects really are? Share your thoughts below, hit that like button, and subscribe to Future Facts for more mind-bending space discoveries. Until next time, keep looking up.